All right, we're going to kind of bridge the previous section with the next section with this one generation of computers. I'm going to call the electromechanical computers, which use a device called a relay. So all the previous generations relied on gears, pulleys, springs, punch cards, things like that, very mechanical devices without electricity. Now, the next generation will use fully electronic devices, but we have a time period in the early 20th century that kind of use both, and I'm going to explain how that worked. Now, you may be familiar with relays because relays are used to this day in many different devices. Your air conditioner, for example, your car, all these devices have relays. So many types of machinery today has relays. So here's how a relay works briefly. Let me kind of introduce you to in the real world sense that you would see today, and then we'll talk about how it works with computers. Um, let's say your air conditioner. The way this works is you can have electricity coming in on this, let's say these two prongs here. I'm not sure if that's going to show up in your screen here. There we go. And if electricity is coming in through here, it will activate a large electromagnet in this section right here. Now, electromagnet is one that is only creates a pull or a force when electricity is applied to it. It's not a regular magnet; it has to require electricity. It's a coil of wire generally. A coil of wire will create that, and so when you add the electricity, that coil of wire will create a magnetic field. Now, when that happens, this entire middle section is held up by a spring. When the electromagnet turns on by these wires, that pull is stronger than the spring, which means this entire section gets pulled downwards. Physically and mechanically, it pulls downwards. When it goes down, it will connect these plates down here, which means this is now connected to this plate through the bottom of this plate, or this little section. In each side is wires coming in and wires coming out. So if you think about it, when this goes down, we now have a bridge so electricity can now flow from these two prongs through here and out the other side. Whoops, didn't mean to click there. Now, and so here's an example of how that would work in your home. Your air conditioner. You can send from your thermostat in your house, the little thermostat can send 24 volts, which is not very much, just 24 volts electricity into a relay outside on your air conditioner. When that thermostat says turn the air on, it sends 24 volts down this wire. It activates the electromagnet. It pulls that entire box area down. It makes contact here, and 220 volts is ready and waiting on these prongs to continue through and turn on the compressor. So you have a little voltage turning on a large amount of voltage. And that's generally how relays work, in your car, and many other different examples. Now, let's kind of look at that in light of our punch card from the previous device. We use punch cards to store a 1 or a 0. Well, in that case, once the card was punched, it was always punched. But now, with a relay, they can apply voltage, and when they apply voltage, when you check the value of this, it now has current. It now has electricity flowing through it. When electricity is not sent through this, it will not have electricity. It will show 0 voltage. So think of this as a switch. Think of this as a binary device holding a 1 or a 0. And instead of you mechanically or your finger pushing a switch, electricity is now turning that switch on or off. And that can be done very quickly. But mechanically, you'll still hear the clicking and the clacking of these relays going up and down. And that's the mechanical part. That's why we call these electromechanical, because electricity is the main source of how this works, but it's mechanically being connected together. The connections are being made mechanically through these electromagnets. So if you here's an example of an older computer from probably the 1920s, 1930s, and you can see why these computers had to be so large, because imagine if you had to have, let's say 8 of these were required to make one number, and you need to hold hundreds or not thousands of numbers. It would take thousands of these relays in order to build a machine that could perform large-scale math problems. So hopefully it's a shorter video. on the bridge between electric computers and mechanical computers. The device that they used was called the relay. This is an example of it. This is actually a modern relay, probably out of an air conditioner, but the same concept were built into these machines, and that is going to be kind of the bridge. And next time we're going to move to fully electric computers that have no moving parts or work fully on electricity.